Right. So let us see the response of series RLC circuit, in which what we take is resistor, inductor and capacitor, three elements which are connected in series as like this. So let me take the R, and whose value is capital R, and it is connected in series with some inductor whose inductance is L, but inductive impedance is JXL in frequency domain. Similarly, so we have a capacitor whose capacitance is a C, but its impedance in AC system is minus JXC. And these three elements are connected in series as like this. And if I have some total voltage across this entire system is V bar, here to here the applied voltage is V bar. As a result of this voltage, we may have some current passing through this series circuit, and as current pass through this series circuit, then we will see some voltage across the resistor, which is, let us say, VR bar here to here, and also we may see some voltage across the inductor, which is VL bar. Everything is in phasor, try to observe. And we may see here voltage across the capacitor as VC bar. So these arrows represents that this arrowhead represents positive, non-arrowhead represents negative, as like this. In DC system, if we compare the DC with the AC, arrowhead points the positive, non-arrowhead points the negative. So this is what the series RLC circuit. Now let us assume that some voltage or current, it's your wish, there is no fixed hard rule in this, but preferably in series circuit current is common through every element, so we choose let the current I bar is equal to I at an angle of 0, that means the current might be something like this. I of t is equal to Im cos omega t plus 0 in this form. If we convert this I of t into phasor form, what we get is I at an angle 0, where I is the RMS value of the current, which is equal to Im by root 2. Clear? This is what the current. This is our assumption that current is in this form. So if so, we determine rest of all the parameters. Let us see how we determine. So now if we know the current, then can we find voltage across this resistor by Ohm's law?
Sir.
So voltage across the resistor, which is VR phasor, is equal to current into resistance. So how much is the current is I at an angle 0, resistance is R. So simply this is equal to IR at an angle 0 degree. This is what the voltage across the resistance. Similarly, let us take the voltage across the inductor VL bar. How we find? The same current is also passing through the inductor I into its corresponding impedance. How much is the impedance of this inductor? Is ZL, which is equal to JXL. So I can write this as initially ZL, I into ZL, which is equal to I at an angle of 0, whereas ZL, so we had seen that, so ZL can be written as in polar form or rectangle form as JXL, or simply XL at an angle of 90 degrees. We seen that J is equivalent to 1 at an angle 90. So you can replace J by angle of 90 simply. Similarly, capacitive impedance ZC is equal to minus JXC, which can be written as XC at an angle of minus 90 degrees, as like this. Means these are the rectangle forms, these are the second things are the polar forms, which are having magnitude and angle. Whereas rectangle form, it look like real part and imaginary part. What is the real part in this? 0. 0 plus JXL, 0 minus JXL, like that. Okay. So now I can write ZL as because it is multiplication, preferably in multiplication use the polar form, which is XL at an angle of 90 degrees. Then in order to get these things, so you can just multiply the magnitudes and add the angles, that is I into XL at an angle of 0 plus 90 is 90 degrees. What is this? Voltage across the inductor. Now similarly, let us find voltage across the capacitor also. Vc is equal to, same current is passing through the capacitor also, I into Zc, which is equal to I at an angle of 0. Zc is Xc at an angle of minus 90. Xc at an angle of minus 90, which is equal to Ixc at an angle of minus 90. Now, by using KVL, by using KVL, by using KVL, what can we do is that the total voltage across this entire RLC combination is sum of the voltage across the resistor and voltage across the inductor and voltage across the capacitor. So, now I can write V is equal to VR bar plus VL bar plus VC bar. See that this is phasor addition. It is not simply VR magnitude, VL magnitude, VC magnitude. It is phasor additions that you should carefully observe. Everything we are writing as phasor form. So, how much is VR is IR in at an angle of 0 plus IXL at an angle of 90 plus IXC at an angle of minus 90. Now, whenever additions are there, try to express these things in rectangle form so that we can add up all real parts and all imaginary parts. Okay. So, now I will make this into some rectangle form as simply IR. IR at an angle 0 is equal to IR plus J I XL. Why? Because angle 90 degrees is equivalent to J. Just now we had seen. So, this is minus J I XC. Now, if we take the current common out of all these things, it look like I into R plus J is common for these two terms, which is imaginary. So, if I will take J common, I will get XL minus XC. XL minus XC. This is what the total voltage V. Now, try to observe this entire impedance, this entire thing, I can treat as total impedance of the circuit. See that if I will consider the total impedance is sum of each of the elements impedance, that is what? Resistive impedance, inductor impedance, capacitive impedance, ZC. If I will add up all these things, how much I will get? Check it. R plus JXL minus JXC. Now, if I will take common this J, what I will get is J into this is L XL, XL minus XC. Now, try to observe it is in the form of A plus JB form, that is rectangle form. So, can I convert this into polar form as like this? Magnitude of the real part, which is R square, plus magnitude of the imaginary part XL minus XC whole square. This is what the magnitude. How much is the angle? Angle is tan inverse
of minus B by A.
B by A, which is XL minus XC by R. So, XL minus XC, real imaginary part divided by real part. If imaginary part is negative, then we take negative also. Okay. Now, this entire thing, instead of writing every time this much big expressions, what I will say is that this is the magnitude of ZT. Magnitude of ZT I will represent as mod ZT. The angle I will represent as theta. Where let me write mod ZT is magnitude which is equal to square root of R square plus XL minus XC square, where theta is the angle which is equal to tan inverse of XL minus XC by R. Now I can put this R plus J XL minus XC as ZT, this entire thing as ZT, but ZT can be written as mod ZT at an angle theta. So I'll write this as I mod ZT at an angle of theta. So this is what the total voltage across entire RLC combination. Entire RLC combination. Now if you want, just you can even go with the phasor diagram. Just I will show quickly that. So we have current. So current is some angle. Let us say current is at an angle of 0 that we had seen, 0 degree, whose length is I. See this, how much is the current? Current is I at an angle 0. That means length of this phasor is I, angle of this phasor is 0. So 0 degree is, this is what the reference. If I will consider this is 0 degree, so this current should lie along this 0 line. Now I into R at an angle 0 is what the VR. So now VR angle is also 0, so it should lie on the same line, but it may have more length than the current. This green color is what the VR magnitude. How much is the VR magnitude? I into R. What is its angle? 0. That's why it is lying on the 0 axis. Next is, so our inductor voltage. See that, how much is the inductor voltage angle? Plus 90. So plus 90 is, in anti-clockwise direction, angles are referred as positive angles. So here I will try to draw some VL magnitude whose angle is 90 degrees. Whose angle is 90 degrees. Similarly, I will try to put up the capacitor voltage also here, but whose angle is minus 90. Minus 90 means in clockwise. So here I will try to put up the capacitor voltage VC bar magnitude, but this is in clockwise at 90 degrees. So this is the phasor diagram of this series RLC circuit. And now if we make one more step ahead out of this, just this phasor diagram, so we can make some more interesting thing, that try to observe. When we add up all the voltages, that is resistor voltage, inductor voltage and capacitor voltage, if inductor voltage is at 90, capacitor voltage is at minus 90. So how much is the total difference from here to here? Is 180 degrees. One is at minus 90, another is at plus 90. Thereby the difference between them is 180. See this, VL is upward, VC is downward. Now for example, if something is given that VL is more than VC, if somebody told you that VL is having more value than VC, just for this case, just I want to show the phasor diagram, and let me wind up this. So I have already VR magnitude, and now VL is on the top side, VC is on the bottom side. So VL is more value, so that VL I am trying to put on the tip of VR. This is what the VL magnitude, and VC magnitude is downward, but it is lesser value. Now see that this is VR and this is VL, this is VC. Now as a result, when I add up VL and VC, what happens is that, let me take one more step beside this. See that, so if I will add up this VC which is negative to this VL, then left out thing is the difference of these two. Then how much is left out thing is, if I will deduct this amount of the green color length, then that left out whatever it is there, which is equal to this much, is what? VL minus VC magnitudes. Red color one is the difference, VL minus VC. Now VR plus VL minus VC is what? The final total voltage across the RLC circuit. This is what the V. And V is making an angle of theta. See here, V has an angle of theta, positive theta. So this angle made by this is what? The theta. So in this way we can make the phasor diagram when VL is greater than VC condition. If it is some other condition, you can interpret how it look like. Just let me show that also. One second. If VL is less than VC magnitude, I am talking about only magnitudes. So how does it look like is that here is our VR, no change in the VR magnitude, but VL is now lesser value and VC is more value, as like this. This is what VC, this is what the VL. Then difference between VL and VC, how we get is that just subtract this amount of the VL from the VC, you subtract this amount of, you decrease the VC by this value, and the left out value is what? The left out value is what? The difference, which is indicated here with the red color, which is VC minus VL. As because VC is more, so I am taking VC minus VL. Previously VL is more, so I am taking VL minus VC. Clear? So next is the VR plus VC plus VL, all these additions is what? Is what? The total voltage across this RLC combination, which is equal to V bar magnitude. And here in this case we may get angle as negative, so which is equal to theta. This is for the case VC is more than the VL. Like this we can take up different cases. So anyhow, so this is one of the important concept, that phasor diagram of RLC circuit for these two cases. Okay, how I drawn all these things is based on these expressions only. See that VR is 0 angle, VL is 90 degrees, VC is minus 90, etc. like that. And just let me give you one more point, that just try to observe here the impedance of this RLC circuit is R plus J XL minus XC, which can be expressed in polar form as mod ZT at an angle of theta, where this impedance angle, let me write here, this impedance has some angle. How much is that angle? Is theta, is referred as power factor angle. Power factor angle. Impedance angle can also be referred as power factor angle. And generally we come across this term, that power factor. So let me define the power factor also here. The power factor is usually represented as PF, which is the cos of this impedance angle, or in simple form we can also write cos of the angle of the voltage minus angle of the current. Angle of the voltage minus angle of the current. That is what the power factor. Usually this impedance angle is the angle between voltage and current. You can see this. The current is there here somewhere, as in the first diagram. Check it here. Let me show this. See here. Here is the current. So voltage across the resistor and current both are same. So I can say The angle between current and voltage is what? Theta. So indirectly we can say the power factor angle is what? The angle difference between voltage and current. Okay. So with this, now let me take one problem and let us see one important this concept through this problem also. So a series RLC circuit is connected to a 230 volts 50 hertz single phase supply. See here, what is given is voltage is given for us. Voltage is given for us. Remember carefully that whenever voltage is given, the given voltage is treated as a RMS value. Remember this point. They will not specifically give you as RMS value of the voltage is this. And treat that this is the magnitude of the given voltage. So this is what the total voltage across this RLC circuit. If we see this RLC circuit previously, this is what the RLC circuit. This entire RLC circuit is connected across this voltage. Let me take the copy of this again. See here. So so whenever you see this circuit kind of problems, so try to draw the circuit so that it gives the better understanding how to solve the problem. Now what is given is that voltage is given, which is connected across this entire RLC circuit. Now so let me write that given thing as V bar is equal to, it has magnitude and angle. How much is the magnitude? 230 volts. Then angle, if it is not given anything, you choose as 0 degree. So this is the standard procedure that if current is given, we take current itself as a reference. If voltage is given, we can take voltage itself as a reference. Nothing wrong in it. Okay. Previously, I assumed current as a reference, then I try to calculate remaining all parameters, that is VR, VL, VC and total voltage V. If voltage is given, then you can calculate all current through the branch and voltage across each of the branches. So it's not a big issue that which is reference. Okay. So here as because voltage is given, so I am considering voltage itself as a reference, which is having angle of 0. Now, so next what we need to see is that the values of R, L, C is given, but in general in frequency domain, especially whenever you see this term, see here this term 50 hertz. Observe that this is AC system. It is AC system. So in AC, we should definitely calculate the impedances of each element. Okay. So how we calculate the impedance is that inductive impedance ZL is equal to JXL, where XL is referred as the inductive reactance, which is equal to omega L. So instead of directly like this, let me calculate the XL first, then later I will substitute there. XL is what? The inductive reactance, which is equal to omega L, where omega can be written as 2 pi f into L. Then how much is this? 2 pi f is 50 hertz and L is, how much is the L value? 13 millihenry. Milli means 10 power minus 3. So you simplify this and give me the value. So how much we will get this value is, so let me calculate. Two pi into 50 into 13 into 10 power minus 3. So this is 4.084 ohms. This is what? Inductive reactance. Similarly, we will have capacitive impedance, which is equal to minus jXC, where Xc is referred as capacitive reactance, which is equal to 1 by omega C, which is equal to, omega means 2 pi f. So C is already there, so C. Now substitute these values. 1 by 2 pi into 50 into C is, so how much is the C value? So 140 microfarad. So 140 micro means into 10 power minus 6. So let us calculate this value also. 1 divided by 2 pi into 50 into 140 into 10 power minus 6. So how much I got is that
22.73.
22.736 ohms. Right, very good. Now I got the total reactance of these circuits. See that inductive reactance is XL and capacitive reactance is XC. Now in the total impedance of the circuit ZT, try to see how I will get is first element is resistor, so its impedance also resistance. Second element is inductor, so its impedance is ZL. Third element is capacitor, so its impedance is ZC. Now if I will put all these things together, what I will get is that JXL minus JXC. Now if I will simplify this entire total impedance as substituting all these values, R is 5, so 5 plus J into J I can take common, so how much is the XL? XL is 4.084. How much is the XC? 22.736. So XL minus XC. So then if I will simplify this, XC is more, so I will be getting this as minus. So how much I will get? 22 point this minus
Minus
4.084.
18.652.
Okay, very good. So minus 18.652 J. Now try to see in this impedance what is the real part. Real part value is minus 18.652. This real part is generally referred as total reactance offered by this circuit. This series RLC circuit has two reactive elements. One is offering XL, another is offering minus XC. So total together is when you combined this total impedance, the imaginary part in the total impedance is referred as the total reactance. Total reactance is equal to 18 point. Of course, it is negative, but so it is capacitive in nature. If it is negative, so I can say value is 18.652 ohms. This is what the first bit. And second one is total impedance. The impedance is already calculated. So the total impedance or simply impedance, the impedance is ZT, which is equal to 5 minus 18.652, but preferably express this in polar form. Just convert this into polar form. This is in rectangle form. So now let me put this into polar form. 652. How much I will get is 19 point, magnitude is 19.31, angle is minus 74.99 degrees. So next, what else is there? The current drawn. So how much is the current? That can be obtained, the current, as simply like this. I bar is equal to the total voltage divided by the total impedance ZT. As like this, see here, I need the current voltage divided by total circuit impedance, which is ZT. This entire thing we obtain as ZT. So if I want I and V relationship, I can directly write V by I is equal to ZT or I is equal to V by ZT. So that what we are doing. So how much is V? Is 230 at an angle 0. And ZT can be written either in rectangle form or polar form, but here it is division. So if I will write in polar form, it is much more helpful. So 19.31 at an angle of minus 74.99. So this value is, how much is this? Check it. So 230 divided by the answer which I already did. So this is 11.91.
sir.
Yeah, very good. So at an angle of
74.99.
74.99. Very good. So this is what the current. But if I need only current magnitude, so I can say mod of this which is equal to magnitude of this. How much is that value? So magnitude of this is what? This much. So which I can say 11.91 amperes. Nothing wrong in expressing polar form as magnitude and angle. But if somebody asks only current, that only express the current magnitude value. So which is equal to 11.91. Then the final one is the power factor PF. So PF is the cos of the angle between voltage and current. If you know voltage and current both, directly you can do like that, or if you already know the impedance angle, directly put that angle. We already calculated impedance. See, angle is already known. How much is the angle? 74
minus
point this.
74.9.
So now we can put that thing over here, cos of minus 74.99, but whether it is minus or plus, it doesn't matter. This negativeness is expressed, I will tell you. So first find this value, cos of 74.99. So how much is this? 0.258. So see this, as because here try to observe, XL is 4.084, XC is 22.736. So if we observe carefully, XC is more than XL, and that means if XC is more, means capacitance nature is dominating. So we already seen previously, in case of capacitors, the current leads the voltage. Current leads the voltage in case of capacitor. This you should remember, these points, important points. If it is the inductor, current lags the voltage. Okay. If inductor is dominating, then current lags the voltage. So that negativeness here, whatever negative is there, this negative factor, that will be named here as leading, as because it is capacitive nature. Okay, just we will not say there is a difference between like cos of plus 74 or minus 74, but that negativeness is said as leading nature. So in this way we can do the power factor calculations. See here that it is a series circuit. What does this circuit contains? One resistor and one inductor. Just up to these words, let us draw the diagram. So what we have is that a series circuit in which we have resistance and we have inductance. Okay, this is what the given information, and resistance is R, inductance is L. So what happens next? This circuit has voltage and current in this way. Now let me put, how much is the current? Tell me, I of t, that expression, and how much is the voltage? Voltage applied is V of t, as like this. Now these are in the time domain. In the time domain, in the sense that everything is function of time. Now from the given information, so I can write I of t as 5 sine, tell me, 314 t. How much is 2 pi by 3? Is it 120? 2 pi by 3 degrees, in degrees, 2 into 180 by 3, which is 120 degrees. 120 degrees in degrees. Just I am converting 2 pi by 3 radians into degrees. Okay. Now, can I express this current immediately into phasor form? As like this, I bar is equal to magnitude. Which magnitude? RMS value. How much is the RMS value? 5 by root 2 at an angle of 120. At an angle of 120. Is this clear? So if you want, you can simplify this 5 by root 2 also, no issue. So let us keep
3.53.
So let us keep for the timing as it is. Why? Because we need more accuracy. So next is voltage. V of t is given. How much is the V of t? 15 15 sine 314t plus how much is 5 pi by 6? 5 pi by 6 is 150 degrees. 5 pi by 6 is 150 degrees. So, I am expressing the given radians into degrees, that is all. Now, can I say this voltage also in phasor form as V bar is equal to 15 by root 2 at an angle of 150. So, I got voltage and current phasors. Now, as because I already got in phasor form, I try to produce this circuit also into phasor domain. The resistive impedance is R, no change in this, whereas inductive impedance is ZL, which is equal to JXL. And this is what the total voltage which is in phasor form V bar and the total current which is I bar, and the impedance, total impedance of this circuit is ZT. How much is ZT? Can you tell me from the previous knowledge? Can I write ZT as first element
R
impedance is
plus R plus
ZL?
JXL.
Exactly. R plus ZL is JXL. So, let me keep as it is here. And if you want, you can make this into something like magnitude mod ZT at an angle theta form, where mod ZT is equal to square root of R square plus XL square. How much is theta? Tan inverse of XL by R. This is what ZT. Now see that just now we had written in the previous problem that if I know voltage and current, can I write V by I is equal to ZT? So, from the given information, V to I ratio in phasor form is equal to ZT. And how much is V? 15 by root 2 at an angle of 150. How much is I? 5 by root 2 at an angle of 120 is equal to what? ZT. So, let us take up one more step ahead in simplifying this. We see some interesting things. So, this is division. So, root 2 will get cancelled and 5 3s are 15. So, 3 at an angle of 150 minus 120, right? 150 minus 120 is equal to what? ZT. And can we make this as 3 at an angle of 150 minus 120 is how much? 30 degrees.
30.
Now, this is in polar form. Can I express this into rectangle form? As 3 at an angle of 30 degrees is equivalent to say as how much I will get is, let me check, 3 root 3 by 2 and 3 by 2. So, let me write directly 2.598 plus 1.5 J is equal to ZT. But ZT we already seen, see here, ZT is equivalent to R plus JXL, is not, in our circuit. So, ZT is actually equivalent to R plus JXL. Now, can I compare real parts and imaginary parts on the left side and right side? Compare real part and imaginary parts. How much I will get? R?
2.598.
Exactly. Directly I am getting 598 ohms. How much is XL?
1.5.
1.5 ohms. But we already know that XL is equal to omega L. So, which is equal to 1.5 now. So omega can be written as, how much is omega now? Can you see the current or voltage? See this. This value is what the omega? 314. Why? Because it is 5 sin omega t plus theta format. Every time they will not say omega is 314. You should understand that. So if frequency is given, you can write 2 pi f. But frequency is not given. Instead of that, omega is given here. Okay. So now, so with this, so omega is 314. Is that 314?
Yes,
Yeah,
sir.
yeah. So 314 into L, which is equal to 1.5. So now you can get the value of the inductance as L is equal to 1.5 by 314. How much we will get? So 1.5 divided by 314 is what the inductance value, which is equal to
7,
4.77
sir.
into 10 power minus 3. So I can write as millihenry. So I got the resistance value and inductance value. See here. Initially I got inductive reactance, and if I will expand that, I got the inductance value. So what is the question? See here. Impedance of the circuit, which is already we got here. How much is the impedance? 3 at an angle 30 degrees. If you need that to be in rectangle form, you can consider that 2.598 plus 1.5j in rectangle form. Okay. So this is first question. Next, second question is the value of the R. We already got, this is what the second question. Next, value of the inductance. This is what the third question. So what else is left out? The power factor of the circuit. So how can we get power factor angle? First of all, in order to get the power factor is cos of the impedance angle. Do we know impedance angle? We already know. See, how much is the total
30,
impedance?
30 degrees.
30 degrees. So directly we can get. So this is equal to cos of 30 degrees. Clear? So how much is cos 30?
Root 3 by 2.
So cos 30 is root 3 by 2, which is equal to 0.866. Now as because angle is positive, so we can say that positiveness as lagging. Why I am saying lagging? Why? Because there is no capacitor in the given circuit, only inductance is there. Wherever inductance is dominating, we say current is lagging the voltage. It is the default nature of the inductor. Once inductor is there in the circuit, only inductor, definitely current lags the voltage. How much is that we need to calculate? How much it lag is, that depends on the angle. Here it is lagging 30 degrees. That is what the impedance angle, which is equal to lagging angle. Okay. So in this way we can proceed. This is of one different kind of problem. So read the every statement of the given problem. So here what is the given circuit is RL circuit. If it is not specified whether it is series or parallel, so treat it as a series only. Clear? Treat it as a series. So next is, the moment you see this, let us draw the diagram. As R and L in series. And as because we are dealing with the frequency, that is AC supply, alternating supply, there itself try to put its corresponding impedances as R and J, XL or simply ZL. And this is what the total impedance of the circuit. And for which, let us calculate quickly how much is the total impedance. This is the total voltage, and current through this is, just indicate, these are very common once we take up the circuit. So see that how much is that ZT? ZT is equal to R plus JXL. So how much is R and how much is JXL? JXL can be written as omega L. So how much are these values? Let me write. R is 2.5 plus J into omega is not given directly, but it is given in the form of frequency. So 2 pi, F is 50 into L is 0.2. This is entire imaginary value. How much we will get? See here. 2 pi into 50 into 0.2 is 20 pi, which is equal to this is 2.5 as it is, plus 62.83 J. If you need, you can express this in polar form also. So 2.5 plus 62.83 in polar form. So how much is that value is? So let me see. 62.879 at an angle of 87 point, how much you got? 72. Is this correct? Ohms. This is what total impedance ZT. Why I calculated ZT is there is some advantage. I will show that. Next is V is already given. V they had given as 230 at an angle of 30 degrees. Now what I need is that current. So can I say current as V by ZT? Simple thing. So V is 230. Usually we have 0 degree, but here it is given some 30 degrees. So no issue, whatever it is given, we take that. So divided by ZT is 62.879 at an angle of 87.72. So if you simplify this, so how much you will get? Check it. So 230 at an angle of 30 degrees divided by this previous answer.
3.657, sir.
Exactly. So 3.657 at an angle of minus
30 minus 57.7.
50.72. Exactly. So amperes. Okay. So I got current. Next what I need? Power factor. It is simple now. Once you got the impedance, now just look at the impedance angle and you will get the power factor. Okay. So this is, one is current, 2 is the power factor. So PF is equal to cos theta. How much is theta? 87.72.
87.72.
So how much we will get this? Cos of 87.72 is equal to
0.0397.
0.397 lagging. Why? Because inductive circuit. So I am taking this as lagging. So in this way you can evaluate the current and power factor.
So now let us move on to the RC circuit problems. So far we discussed about the RL circuit. Now let us discuss some RC circuit problems also quickly. So here a voltage of 35 is applied across CR series circuit. CR or RC, both are same. It doesn't matter. So let me take a R resistor and a capacitor. So how much voltage is applied? 35 volts. So next, what we need to do? If voltage across the resistor is 21 volts, this is the resistor, this is the capacitor, but I want to show in frequency domain, this is minus j xc, minus j xc. And they clearly stated that voltage across the resistor is how much? Tell me. So indicate that across the resistor, this is 21 volts. Across the resistor is 21 volts. Next, what we need to do? We need to find voltage across the capacitor. So let me indicate that this is VC. Try to see that I am putting magnitudes only. I am not putting any bar over here. If I'll put hyphen bar here, it becomes phasor. If I'll remove it, it is magnitude. That is the meaning. So now here again more or less the same kind of phenomena from the phasor diagram you can get quickly here. So now I don't want to draw the current, just I will put up the things as like this. First let us say current is in phase with the voltage. This is the resistor voltage and current also in phase with this. So let me put as, just for time being, later on I will not show the current, just these things. This black color one is the current and green color one is the resistor voltage. resistor voltage. And we know for a capacitor, current should lead the voltage. Do you remember that expression? Current should lead the, this is VR magnitude. So this is current magnitude. Which current? Total current magnitude. So where is the total current? Here is the total current, I phasor. Now where should be the voltage of the capacitor? Capacitor voltage should be downward, so that now current is leading the voltage. So this is what the VC magnitude. VC magnitude. See the importance of phasor diagram now. So, but to get some things clear visualization, I will put up this VC at the tip of VR. Both are equivalent. Now, the phasor sum of VR and VC is the total voltage, resultant voltage. So, that is what the source voltage. This is the source voltage. How much is that? Here it is given Vs magnitude. Vs magnitude is given to you. Now again, from the simple principles, a right angle triangle this also. So now can I put the things as like this, as what we had seen? Vs magnitude square is equal to hypotenuse is equal to Vr magnitude square plus Vc magnitude square. Now you find the unknown, very easy. So now what is Vc? We need the capacitor voltage. So Vc is equal to square root of Vs square. How much is the Vs? 35 minus Vr square. How much is the Vr? 21 square. I wrote the answer directly. How much is this? Somebody tell me. 35 square minus 21 square. 28 volts. Yeah, fine. 28 volts. So see the importance of phasor diagram, that should be on the tip of your fingers. So you should be very careful about the phasor diagram. So next is the second one. A resistance of 50 ohms is connected in series with a capacitance of 20 microfarad. So draw the diagram again. That statement I will put in the form of diagram. There is a resistor. Next, I want to add this in series with a capacitor. So I want to put up the capacitor. So next, what happened? If a supply of 200 volts is connected, so this combination is connected across a supply of 200 volts. 200 volts. And just I want to highlight one point about this supply in the previous problem, that, sorry, 200 volts. Yeah, fine. So just see here, they said that a voltage is applied across the RC circuit. They did not said what kind of voltage is this. So if it is not specified anything, it is treated as AC supply only. If it is clearly given that it is a DC, then only consider DC. One thing. Other thing is that they did not specify about the magnitude. Is it RMS value or peak value? So until unless it's specified as peak value, so we will consider generally as RMS only. So it is supply is AC, given value is RMS. This is by default understanding in AC systems. If it is not given any information, you should treat that it is AC supply, the given value is RMS value, and it is only magnitude. So now let me put up these values here, 50 ohms, and next what else? So this is 20 microfarad. Just I want to make in this way, as it is frequency domain minus jxc. But I'll write jxc or xc here. Xc is equal to 1 by omega c or 1 by 2 pi f c. How much is this value? Can you Tell me. 1 by, substitute all this, 2 pi, F is 100 and C is 20 into 10 power minus 6. How much is XC? Quickly. 1 divided by 2 pi 100. Yeah, 20 into 10 power minus 6. 79.577. Is that clear? Everyone got same thing? 79.577. What are the units? Ohms. So now here, can I put up this as minus J 79.577? If it is directly given as XC, I would have written, but they did not given. They given only capacitor. So I calculated XC and I had put up those things over here. Now simple thing. First question is that circuit impedance. What is the circuit impedance? This is a series circuit. So circuit impedance is inductive impedance plus capacitive impedance. How much is the inductive impedance? 50 plus capacitive impedance is minus J 79.577. And what we need exactly is magnitude. So, or we need polar form. So, can you put up this in polar form? 50 minus, so 79.577. So, I, then your answer should be in the polar form in your calculator. So, this is 93.98 at an angle of 57.85 degrees. Now the thing is, impedance means we need the magnitude of the impedance is 93.98 ohms. This is what the answer. Next, what else we need? The current flowing. So current means I need only current magnitude. So for which just previously we had seen current magnitude is equal to voltage magnitude divided by Vs magnitude divided by Zt magnitude. So Vs magnitude is known. How much? 200. Zt magnitude is just we calculated 93.98. So how much is this? 200 divided by this one. 2.128 amperes. What else we need? Phase angle between voltage and current, for which so one can directly put up the things or just you can see in this way. So if let Vs phasor is equal to Vs at an angle of 0. What is Vs is 200 at an angle of 0. In this way you can assume, or you can assume current as a reference, you calculate the voltage angle, either of the way. So if you means think about all these things, you can try to observe that previously we did this thing, phasor diagram. So this is an RC circuit, sorry, this is amperes. This is an RC circuit. See, in RC circuit, what kind of phasor diagram we got? Just now we drawn. So this kind of phasor diagram we get. So let me put up this diagram over here. Just I am putting that diagram over here. Now, what is the theta? So you can observe theta is the angle of the impedance. So here theta is the angle of the impedance as like this. So theta can be written as tan inverse of xc by r, xc by r. That is imaginary part divided by real part. That is of course tan inverse of minus xc by r, or that minus is already considered in clockwise, so it is tan inverse xc by r. So what is xc? So you can write the same thing as tan inverse of So opposite side is Vc magnitude divided by Vs magnitude. So in this way, in many ways you can write out. So above all these things, the ZT we already calculated as 93.98 at an angle of how much is that? Minus 57.85. So this is what the theta. You no need to put any effort, just directly you can blindly think of that. This is the theta. So minus is considered already over here in the clockwise direction. So now theta is equivalent to 57.85. One can directly put up like this.